Hello again guys, I hope you're doing good. Okay, now in this video we're gonna start to learn a little bit more about electric variables. Okay, um, you can use the book, you have the different explanation there, but I'm gonna show you a few ideas about what electrical variables are. Okay, a variable is, in Spanish we call that magnitud, ¿vale? Es algo que puedes, una variable es una cosa que puedes medir. For example, we have in physics, you can measure the mass and you use the gram, or maybe you can use the time and the unit is the second, distance, the meter. So you have different things that you can measure. In electricity, we're gonna use three variables, and the variables are voltage, current, and resistance. Okay, so let's start to remember what electricity is. Okay, if you remember from the beginning of the book, we started analyzing what the matter is made of. So as you know, matter is made of atoms, and in atoms we have the nucleus with neutrons and protons, and we have the electrons with negative charge. Okay, so what is the electricity? So electricity is when you have different atoms together, when you're able to force the electron to jump from one atom to another. Okay, this is what we call electricity. Okay, is the flow of electron, as I say, jumping from one atom to another. In nature, we can see this, for example, in a store, in lighting. The lighting is formed by millions of electrons that jumping from the cloud to the ground. Okay, so this is one way we can see electricity in real life. Okay, so when we have a conductor, for example a wire made of copper, the electron flow is what we call current flow. This is what we call electricity. Okay, so for example, when you have a circuit, you got a battery, you have a low device, for example a lamp. What you have is are the electrons leaving the negative terminal of the battery, going through the lamp and getting to the positive. Okay, this is the reality. This is the reality. But engineers use the conventional current because in the past they didn't know that the electrons were leaving the negative terminal to go to the positive. So normally what we do is that we imagine that the current is going from the positive to the negative. It doesn't matter much, but it's just the conventional current, the ones we're gonna use. Okay, so the electrical current now, as we know, is the flow of electron, is the number of electron going through a wire and in a certain period of time, and the unit we use is the ampere. Okay, the ampere, and the letter is the A. Electric current, ampere. Okay, so it's more or less like water flowing through a pipe. Okay, we have instead of having water, what we have are electrons. Okay, next concept we're going to talk about is the voltage. Okay, the voltage is what we have inside the battery. The voltage is kind of effort, is more or less how strong a battery is to push the electrons through the wire. Okay, it's like something here inside. Actually, it's a chemical reaction that is able to push the electrons through the wire. Okay, imagine that you have, instead of having electricity, you have water. Okay, you have this water, a chunk of water, and you have this chunk of water. This one is higher than this, so it means that in this one we have more energy. So it's like the voltage. This is like a very powerful battery, and this is a battery with less voltage, with a lower voltage. Okay, when you have batteries, you recognize here cells of batteries. You have different type, but be careful because the size doesn't mean that the battery is more powerful. Okay, for example, you have these 4 different type of batteries. All of them have 1.5 volts, all of them. The difference is that the biggest lasts more. Okay, it takes more time for the battery to run out or to be dead. You have different options. For example, this is a 9-volt battery, and this small one, even if you see that it's very small, this type of battery has 3 volts. Okay, it's more powerful than those batteries over here, but it lasts very few time because it's very small. Finally, we have this typical battery, you know very well, it's a 4.5 volts. So remember, the size has nothing to do with the power of the battery. Okay, so the unit in volt is voltage is the volt, and we use the letter V. Finally, we have a final concept that is the resistance. What is the resistance? Now you remember that we have a conductor with different atoms, and we have the electrons jumping from one atom to another. This is what we call the current. But sometimes it's not that easy. Sometimes in some materials the electron cannot jump easily from one atom to another because they are vibrating or because it's a different material. So this is the opposition to the current flow. This is what we call resistance. Sometimes the problem is that the atoms are very far from each other. For example, this is what happens in the air. So it's very difficult for an electron jump from one atom to another because they are far away. In other cases, maybe the atom don't have electrons available to jump. This is the case, for example, in plastic or in wood, that are called insulator materials. Okay, so it depends on the many things. So we can classify material depending on how good they are when it comes to conducting the electricity. So we have conductor. Normally we have all metals, copper, gold, aluminum. Water is a very good conductor. And then we have insulators that are very bad conductor of electricity. For example, we have wood, we have plastic, we have glass. Okay. In some cases we have a good conductor, for example copper, but if we have a very narrow, very thin wire, what we have is a high resistance. In the upper wire we have a high resistance because they have no space. This one in this one we have a very low resistance because it's a wide or a thicker conductor. Okay. Unit. The unit in resistance, the unit we use is the ohm, and we use this Greek letter to identify the resistance. Okay. So now I think you're ready to answer a few questions in a test that you have in Edmodo. Okay. Goodbye, guys.